we're moving on to solving equations, and we're going to be looking at flow diagrams. So my first question is, what is a term? Okay, I'm not talking about the amount of time you have to spend at school between holidays. I'm talking about in algebra, what is a term? So if I look at this equation, I have a term here on the left. It's just a y on its own. And then my next term here is the x squared. And then the term after that is the minus 5x. And then the plus 6 is the final term. So each term starts with a new plus or minus sign, or this one starts with an equal sign, or this one just has nothing in front of it at all. So that's where we can see where a new term is. And we can shuffle them around. So if I have this, I can move these terms around. I can slide this one over there and put that one over here and put that one there, and it will be the same equation. Or I can put maybe the plus 6 at the front, and then the 5x here, and then the plus x squared there. It would still be the same equation. We can shuffle the terms around as long as we keep the sign in front of the term with the term, because it owns the sign in front of it. And it doesn't affect the expression at all if we do that. We can shuffle the terms again. So we can take this 2 over x and maybe move it over here, and take the 4x and move it over here, and take that and move it over there, and take that and move it over there. So that's the same expression, but with the terms juggled around. I can also juggle around the terms in here. I can move this plus 1 over here, move the minus x squared to the front, and move the x to the front. And again here, I can move the 9 and the x. So I can move this 9 and move this x, and I can just shuffle them around inside there. So there's a lot of things we can do in terms of shuffling around the terms when we have an expression. Okay, so terminology. So this here is called an expression. It's a bit of maths with no equal sign anywhere inside. So it's just a bit of maths, bit of algebra, and it's just called an expression. On its own, it means nothing at all. Somebody's just said 2x plus 4 doesn't mean anything at all. Now over here, what we have is an equation. Somebody said that 2x plus 4 has to equal 16. Now an equation is something we can solve. So if somebody said that this is an equation, we can solve it, and we can find maybe one value of x. Some equations have 2 values of x. Some equations have many more values of x as well. So this is an equation. This is something that we can solve. Over here, this is not an equation. It's called an identity. And you can see, because instead of using an equal sign, I've got 3 lines here. So let's call that a trequartz sign. Actually, often people won't even bother to write it like that. So they'll just write it like this. They'll just write 2x plus 4 is equal to 2x plus 2. But this is still not an equation. This is still an expression. An identity. This is still an identity. Why? Because this you can solve it and find the value of x for which it works. This you can't solve it to find the value of x for which it works. And the reason is, these are actually just 2 different ways of saying exactly the same thing. 2x plus 4 is exactly the same as 2 brackets x plus 2. And we know that because we've learned about multiplying out. So we know that if we multiply that out, it will give us 2x plus 4. And so both sides are actually just identical. So hence the name identity. So an expression doesn't have an equal sign. It really has no meaning on its own, unless you say this is an expression for something. An identity, both sides of the identity are exactly the same as each other. You can't solve an identity. And an equation is where the 2 sides aren't always the same as each other, but maybe they would be for specific values of x. So you could solve it to find those specific values of x. Okay, so rules for manipulating an equation. If you want to add or subtract something to an equation, you do it once on each side. So for this equation, I might decide I want to add 4x to both sides. So I do it once on this side and once on this side, just once. And you can see I've lined it up underneath the x's. When you do that, the minus 4x and the plus 4x will cancel out. So you'll get 0 here, you get minus 3 there, equals, and 2x minus 4, oh sorry, plus 4x, 2x plus 4x is 6x minus 15 equals minus 3 plus 0. The plus 0 we don't really need, so we can just get rid of that. Okay, so if you're adding and subtracting, you just do it once to each side. If you're multiplying or dividing, you do it to every term. So remember, this is the first term, this is the second term, this is the third term, and then this is the last term. And let's say I decide to multiply by x, I have to do that to every term. So I'll multiply this term by x, I'll multiply this term by x, I'll multiply this term by x, and I'll multiply this term by x. Now, this says 3 divided by x, and then I've multiplied it by x. Well, dividing by x and then multiplying by x, they're just going to cancel each other out. So you're just going to be left with 3 here. This says 5 times x times another x, so that's going to be 5x squared. This is the same situation as we had over here. You're dividing by x, and then straight after you're multiplying by x, so they will just cancel each other out, and you'll be left with 7 minus 15 times x is 15x. So if you multiply that equation by x, that's what you'd get. Squaring, square rooting, recipping, etc. They all come under indices. So squaring is to the power 2, square rooting is to the power half, recipping is to the power minus 1. So all come under the heading of indices. If you want to do that, well, square root, square root, square root. And so that gives us x plus 4 equals 5, because the squared and the square root are the opposite of each other, and so you could cancel them out. And here again you could cancel them out, and here again you could cancel them out. Now I've just told you something terrible, because what I've just told you is wrong. What I've just told you is it's wrong. It's wrong. We should hide it. We shouldn't do that. It's wrong because when you're squaring or square rooting, you can't do it like we did the multiplying and dividing, where you do it to every term. When you're squaring or square rooting, there should only be one term on each side. So if I look at this equation, then let's just go back to the beginning. I don't have one term on each side. On my left hand side, I've got 2 terms. So I've got 2 terms on this left hand side. I've got this and this, 2 terms. You can only have one term. Now there is a fix, but it's not a pleasant fix. The fix is to bracket these 2 terms. If you bracket them, they become one term. Okay? And now you can square root. You can square root this whole term, and you can square root this whole term. And so you're going to get here, you can't go into that brackets and cancel out those squares, because the brackets act like a protection, like a cage. It's protecting. You can't get into that cage. So you're just going to get a square root outside the x squared plus 4x. You don't really need to show the brackets anymore, because this square root kind of implicates those brackets anyway. And here the squared and the square root are going to cancel out, so you're just going to get equals 5. Now the problem with that is it's no simpler than what we started off with, because the x is now, oh, why is there a 4x in there? There shouldn't be a 4x in there, it should be a 4. So yeah, so it's trapped now, so we can't undo that, we can't fix that, so it doesn't really work. This is recipping. Again, it's very tempting to do this. It's very tempting to do recip, recip, recip. Recip means turn the fraction upside down. That's what it means. Turn the fraction upside down. So if I recip the quarter, I'd get 4. If I recip the 1 over x, I'd get x. And if I recip the half, I'd get 2. But you can't do that. It's not right. I better emphasize that it's not right. I've put the wrong all over it. I'm going to go a step further and I'm going to cross it out with a nice thick red marker to say no, don't do that. If you do want to recip that equation, then really the only way to recip it is to do it by bracketing these two terms first. By bracketing them first, so they just become a single term. And now you can recip that term and recip that term. Now if you want to recip just a number like 5, you're going to end up with 1 over 5 because it's really 5 over 1. So when you recip it becomes 1 over 5. And these are crushed together as a single number. So when you recip it, you're just going to get 1 over 4 plus 1 over x equals this one. You can recip it. It's going to give you 2 over 1, which is just going to be 2. So that's what would happen if you recip it. And it's sort of a bit messy. Now there is a better workaround for this, but it's still not going to be ideal. The better workaround is to do common denominator first. If we do common denominator first, then that's an alternative. It would make them into one term, but without having to bracket them. So we just do common denominator. The common denominator is going to be 4x. So it's going to give us x plus 4. And on the other side, it's going to equal a half. And then now when I recip both sides, then that's going to give me 4x over x plus 4 equals 2 over 1, which would just be 2. That's correct. I'm not sure if it's what we were after, but that's correct now. So that's how you can rearrange that. Same sort of thing here. I want to square it. I desperately want to square it. You can't do that. You can't do that. That's wrong. Because you've got 2 terms on the right hand side. So, no. Again, just really be emphatic about that, because this is a common mistake that students will make. And in maths, it's really important to know when you're making a mistake or when there's a potential for making a mistake. And the reason is, it's a game, it's like football or Monopoly. But imagine in a game of football, Man United are playing Chelsea, and Man United win 1-0. And then at the end of the game, the referee says, right, Chelsea won. He said, no, but we scored a goal, we won 1-0. And the referee goes, oh no, but in the 32nd minute, one of the Man United players fouled one of the Chelsea players. So because you fouled them, you lose. And then the players will say, no, if we foul them, you don't make us lose. You just say, okay, here's a free kick, or here's a penalty, or send somebody off. But we don't lose. You don't wait till the end of the game and then tell us you lose. But that's what happens in algebra. You're solving an equation, you make a mistake in step 3, and you carry on, and some of the things we're going to do are going to get longer and longer. You carry on for another 20 steps, and then at the end of it, the teacher just says, no, this is wrong because you made a mistake in step 3. No one tells you that you're making a mistake when you're making it in step 3, and so it ends up just being catastrophic. It ruins your whole bit of math. Okay, so what can we do here? Well, we can do the same thing as before. We can bracket these terms. We can bracket these terms and then square it. The problem with that is we'll end up with x squared equals 6 plus root x all squared, which isn't great because the root hasn't even disappeared. Why were we squaring it? We're trying to get rid of the root. Another technique here that would work is you could move the 6 across first. So first of all, we could minus 6 from both sides. Just going to cancel that out. So on the right hand side, you're just going to get root x. On the left hand side, you're going to get x minus 6. Then we can bracket these, and then we can square both sides. And now the square and the square root will cancel each other out. Just move that out of the way. And so we're going to get x minus 6 squared equals x. Okay. Now you could go on and expand that. You could write that as x minus 6 times x minus 6 and then expand the brackets if you wanted. But that's how to get rid of the square root in that case. So we found a couple of solutions for what we were doing. Okay. Difference between an expression and an equation. So this is an expression. So what can we do with this expression? We could expand the brackets. That would be easy. We could factorize. Well, it's already factorized. We could substitute. Well, we don't really have anything to substitute. We could add fractions together, do common denominator, or we could cancel down a fraction. But we can't solve this. So you can't solve it. No, it doesn't have an equal sign. You can't solve it if it doesn't have an equal sign. So don't try and solve it and end up with some weird answers like x equals 4 and x equals -1, because it doesn't. Because that's not an equation. It's an expression. It has no solutions. Here again, we could factorize this quadratic. We've been learning about how to factorize quadratics, so we could factorize a quadratic. We couldn't solve it. Here we could do common denominator. We've been learning how to do common denominator. We couldn't solve it though. Okay, now we want to get on to solving and rearranging equations. And we're going to do case 1 first of all, which is when your unknown which you're trying to solve for, which is usually called x, is in only one place. And what we're going to learn now will apply the same when you get to A level, and it will apply the same when you get to university maths. So in A level, you will learn new types of functions like exponential functions and logarithmic functions, and maybe hyperbolic functions and trigonometric functions. And you'll learn all these different kinds of maths that you don't already know. But this rule will stay consistent throughout. If x is in one place, use a flow diagram to solve it. So we're going to remember that always. If x is in one place, use a flow diagram to solve it. Now, when you get good at this, you do the flow diagram in your head. But for now, you still need to convince me that you're good enough at it. So I want to see your flow diagrams nicely written out. Okay, so let's just do a bit of flow diagrams. So, okay, so this is a flow diagram for getting dressed. Okay, so step 1, put on your underwear. Step 2, put on your trousers. Step 3, put on your top. Step 4, put on your socks. Step 5, put on your shoes. And step 6, do up your shoelaces. Now, some of these, if you swap them around, it wouldn't really matter. If you swap those two around, it wouldn't really matter. But if you swapped those two around, it would be terrible. Could you imagine putting on your shoes first and then trying to put on your socks afterwards? That would be hideous. Or if you swap those two around, well, I don't know, this shouldn't work. Not if you're doing up your shoelaces properly, it shouldn't work. You do up your shoelaces first and then try and put them on. That's not going to work. Okay, so the flow diagram tells us the order in which we've done things in order to get dressed. Now, when we want to get undressed, what we would do is we would reverse that flow diagram. So we would undo our shoelaces first, and then we would take off our shoes, and then we would take off our socks, and then we would take off our top, and then we would take off our trousers, then we'd take off our pants, and then go to the shower. Okay, so we're just practicing writing the flow diagram, and the flow diagram has to start from the x. So we have to start from the x. And the way we write the maths makes it obvious how the flow diagram works. So if you look at this, can you see the cubed is sitting right on top of the x? And it's saying I go first. So cube goes first. And then the +6 is a bit further away, but this, the 4, the times 4, is outside a fence. So that's effectively being pushed out of the room, effectively. So the next thing is the +6. And then now we've left the room, and the next thing outside the room is the +4, and then finally the +8. So the flow diagram for that is x, then cube, then +6, then times 4, and then +8. What's the flow diagram for this? We're going to start from the x. You tell me what the first thing is. Yep. And then the second thing? Yep, well done. So once you've done the +5, you can escape the brackets. And the thing outside of brackets is the ×2 and the cube, but the cubed is sitting on top of it. This is just waiting by the side. This is sitting on top of it. So the next thing would be cubed, and then ×2, and then -1. Okay, there's a bit of a trick question. you can only use a flow diagram if x is in one place. So you can't use a flow diagram for this. You have to start from the x. And the first thing you're going to say is, well, which x do I start from? This one or this one? So the flow diagram starts from the x and it doesn't contain any x's inside it once you've started from the x. Okay, the x is here. We're going to start from the x. What do you see next to the x? Yep, the -1. And then, well, the times 5, yeah, and then the divide by 9. I mean, you could combine these together and you could call it times 5 over 9. And the reason is, when you have 5 x minus 1 over 9 minus 3, when you have this, then the x minus 1 is on the top of the fraction here with the 5. You can slide it off of the top. So that's the same as that. You can slide, it's all factorized, you can slide that off the top. So you could write it as times 5/9 if you wanted to. You could write it as divide by 9 times 5, because they're both sort of, this is sitting right underneath and this is sitting right beside it. It doesn't matter which order you do them in. I'm just going to do the briefest version, which is times 5 over 9. So times 5 over 9 and then minus 3 is my flow diagram for that. Writing a flow diagram for this, you start with the x. What's closest to the x? Yep, it's the squared. And then the divided by 5, and then the plus a half, and then lastly the square root. Okay, the x is here, but the term that contains the x starts with a minus. So the term that contains the x, which is this term here, it starts with a minus. When that happens, sometimes it's a good idea to just swap those terms around. So I'm going to do that. I'm just going to swap those terms around. So I'm going to take that 9 and oh, it's not letting me move it. Okay. No, it's still not letting me move it. Okay, I'll just do it manually. A third, I'm going to move the minus x squared to the front, and then this is a plus 9. I move the plus 9 to the back, plus a quarter. So my flow diagram is x, then there's the square sitting right on top of it, and then how do you make it negative? You times it by -1. Then there's the plus 9, then there's the times a third, and then there's the plus 1/4. So a lot of students get this wrong. They write this as x, oops, too thick, squared, and then -9. But that would be x squared minus 9. It wouldn't be 9 minus x squared. So we need to swap those terms around. Same thing again here. We can swap these terms around because the term containing the x, this is the x here, and this is the term containing the x, and it starts with a minus sign. So if the term containing the x starts with a minus sign, you can think about just swapping those terms around. So you can think about, let's see if it'll let me pick this one up. Yep, okay, so let me just swap them around. So I've swapped them around, and now my flow diagram is going to be x, then there's a plus 3, there's a bracket there. Even if we don't show it, we know that the fraction includes a bracket. Then there's a plus 3. Now I'm going to say it's x plus 3 and then divided by 2. Whoops, and then divided by 2. But you know I've done that wrong. Let me just write that again. X plus 3 and then divided by 2. You know I've written that instead of that. I've written the upside down version of the fraction. Well, the way to fix that is to recip it. So if you start at the bottom of the fraction, then when you've finished reading the fraction, which you're reading it upside down, just end with the recip to turn it the right way out. Now I need to make it negative, so I need to times it by -1, and then I need to add 1. So that's quite a complicated flow diagram now. Okay, so these are your 3 flow diagrams that you need to do. And they all contain something a little bit complicated about them. So see if you can figure out how to check your flow diagram. So I'll show you how to check the flow diagram. Say I want to check that flow diagram is correct. What I'll do is I'll pick up my calculator, I'll put in 1.2 store as x, and then I'm just going to type in the original expression. So not even anything that I've done and changed. I'm going to put it back to how it was originally. It was originally like this. So I'm going to type in 1 minus fraction 2 over x plus 3, x plus 3. And the calculator says that's 11 over 21. So I'll just make a quick note of that. 11 over 21. Okay. And now what I'm going to do is x is still stored as 1.2. So I'm just going to say calculator, what's x? And then I'm just going to follow these steps. So I'm going to add 3. Then I'm going to divide by 2. Then I'm going to recip. Remember, recip is x to the power -1. So it's that button there to the power -1. And then times -1 times -1. And then plus 1. And it gives me 11 over 21. So I've checked that that flow diagram is correct. Okay, so that's your first question that you need to do. Okay, mathematical operations and their inverses. So adding 5. What's the opposite of adding 5? It's subtracting 5. What's the opposite of subtracting a half? It's adding a half. What's the opposite of timesing by 4? It's dividing by 4. What's the opposite of dividing by 2? It's timesing by 2. What's the opposite of times a half? It's divided by a half. Now I don't like this last one. I don't like the divided by a half, because it's a very easy way to confuse someone. So you say to someone, hey, do you want to buy this fake Rolex watch from me? Do you want to buy this fake Rolex watch? It's not a real one, but I'm not trying to kid you that it is a real one. Do you want to buy it for me? I'm charging £250 for it. And you say, that's a lot for a fake watch. I'm not paying that much. I mean, I like it. It's nice. It's a good copy, but I'm not going to pay £250 for it. And I say, all right, look, you're a mate. What if I divide the price by a half for you? And you go, yeah, all right. I go, all right, shake on it. We shake on it. And I say, all right, give me £500. And the reason is divide by a half actually means times 2. Divide by a half can be simplified. This can be simplified to same as times 2. Divide by a half and say is the same as times by 2. So the opposite of times by a half is times by 2. And the opposite of times by 4 is times by a quarter. So you can either change this to a divided by, or you can recip this. Do one or the other. You don't do both, of course. Do one or the other. In this case, I did the change the times to a divided by. But when I redid it, I said, no, I'll leave the times alone. I'll change the half to a 2. Just do one or the other. Just reverse one or the other. The opposite of times -1. When you multiply something by -1, you make it negative. So if it was positive, you make it negative. But if it was already negative, you make it positive again. So therefore, times it by -1 is the opposite of itself. So the opposite of times -1 is times -1. It's self-inverse. The opposite of times -1/3. Oh, okay. So, well, it's going to be divide by -1/3. But rather than do divide by -1/3, I'll do times by -3/1. I'll flip the fraction instead of changing the times to a divided by. Okay, so the opposite of times -1/3 is times -3. And the opposite of times 0, it's a trick question. Do you know it? Do you know it? Do you know it? Oh, tell Manna in the class. Tell her you know it. What's the opposite of square? Now students always get this wrong. So this is a common thing that students get wrong. So if I say to you, what is the square root of 25? The answer is 5. It is not plus or minus 5. It's just 5. But if I say to you, can you solve this equation x squared equals 25? Then there are two answers to that. The answers are x is 5 or x is minus 5. And the reason there are two answers is because the opposite of square is plus or minus square root. So the opposite of square is plus or minus square root. Okay, so the opposite of square is plus or minus square root. And so here we get x equals plus or minus the square root of 25 plus or minus 5. Okay. The opposite of square root is just square. The opposite of cube is cube root, and you don't have a plus or minus this time. If you did fourth power, then you would have a plus or minus again. But for fifth power again, you wouldn't. Get it? This says to the power 3, and to the power 3 is the same as cube. To the power 3 is the same as cube. So the opposite of that would be cube root. Reciprocal means turn the fraction upside down. So if you've got 3/4 and you recip it, it's become 4/3. How would you get it back? You just recip it again. So the opposite of recip is recip. The opposite of sine is called arc sine, but we're just going to call it sine to the -1 for now, which is kind of the wrong name, but that's what your calculator calls it. Opposite of to the power 4 is fourth root. And we said that will be plus or minus like square root would. And opposite of to the power half, well, to the power half is square root. So the opposite of to the power half, opposite of square root is square. So square is the opposite of to the power half. Okay, so I want to solve this equation. And it says, if you're solving an equation where x is in one place, use a flow diagram. Okay, so we're going to use a flow diagram. We're going to start with the x. Next to the x is times 12, and then subtract 28. And now we've reached the equal sign. So I'm going to turn it around when we reach the equal sign and say equals 56. Okay, now I want to do the opposite of the minus 28. The opposite of minus 28 is plus 28. So I'm going to add 28 to both sides. Add 28 to both sides. So add 28. Just do it once on each side. Plus 28. Just do it once on each side. The minus 28 and the plus 28 cancel each other out. That's why I did it. So on the left hand side, we get 12x. And on the right hand side, we get 84. Okay, let's carry on with our flow diagram. We need to do the opposite of times 12, which would be divided by 12. Divided by 12. That should take us back to the x. So divide by 12, divide by 12. And that's going to cancel out with the times 12. So that's going to leave us with x equals, and 84 divided by 12 is 7. So x is 7. Let's check it. Let's store 7 as x. So this time, because we've got an answer, we're storing that as x. Store 7 as x. And then let's type in the left-hand side of the equation. So let's just rub that out. Let's type in the left-hand side of the equation. 12x minus 28. Yep, it gives us 56, so we know we've solved that correctly. Next question. If x is in one place, use a flow diagram. So we're going to start our flow diagram from the x. And so we're going to get x. Next to the x is the squared. That's the closest thing to it. Squared. Then there's a times 3. And there's a times 3. And then way off to the side is the plus 4. Plus 4. And then now we've reached the equal sign. And so we're going to reverse those. So minus 4 from both sides. So minus 4 and minus 4. They're going to cancel out. That's why we did it. So that gives us 3x squared equals 16 minus 4 is 12. Now we're going to get rid of the times 3. The opposite of times 3 is divide by 3. Divide by 3. Divide by 3. Divide by 3. That's going to cancel with that. That's why we did it. And so that gives us x squared equals 12 divided by 3 is 4. Opposite of square, remember it's plus or minus square root. And so opposite of squared is plus or minus square root, plus or minus square root, plus or minus square root. And that's to cancel out the squared. So on the left hand side we get x, on the right hand side we get plus or minus root of 4, which is plus or minus 2. So this has two answers, x is 2 or x is minus 2. Both of them will work. We need to give them both. Let's check it. I'm only going to check one of them. I'm going to check the negative 2. So I'm going to negative 2 store as x. I just chose that one because that's probably the more, unusual out of the two answers. So 3x squared plus 4, it should give me 16. It does. So that's been checked. Okay, so this is a half x cubed minus 13 over 2. So our flow diagram is going to be starting with the x. We're going to cube it. And then we're going to times it by a half. And then we're going to minus 13 over 2. And by then we've got to the equal sign, equals 56. So the opposite of that is to plus 13 over 2. So I'm going to plus 13 over 2 and a plus 13 over 2. That's going to be 112 over 2. So I can rewrite it, instead of being 56, I can do common denominator. So I'll write that as 112 over 2. So 112 over 2. And I'm adding 13 over 2 to both sides. And so that's going to cancel with that. On the left hand side it's going to give me a half x cubed. On the right hand side it's going to give me 125 over 2. So they cancelled out. Now I'm going to, opposite of times a half is divide by a half or times by 2. I'm going to do times by 2. Times 2 times 2. That's going to cancel with that. It's going to give me x cubed equals 125. And then the last step is the opposite of cube, which is cube root, not plus or minus this time, just cube root. So cube root, that's going to cancel with that. It's going to give me x equals cube root of 125 is 5. So 5 is my only answer. Let's check it. 5 store as x. And then I'm just going to type in the left hand side of that equation. So that's fraction 1 over 2 x to the power 3 minus fraction 13 over 2. Did I store x as 5? I don't think I did. I did, yeah. 56. Okay. Solve this one. So we've got that situation, we had it before, where the x, the term containing the x, has got a minus at the start of it. So in that situation, what we would do is we would swap them around. So move this one over here and move that one over there. Just swap them around a little bit. Okay. And so that gives us our flow diagram is x times negative 2 plus 7 equals 6. And then we're going to minus 7 from both sides. So minus 7, minus 7, minus 7. That's going to cancel out with that. It's going to give us negative 2x equals 6 minus 7 is negative 1. And then our last step will be divide by negative 2. That should take us back to the x. Divide by negative 2, divide by negative 2. And then that's going to give us x equals a half. So there's our answer, and we can quickly and easily check that. Check it in the original question, not one that you've manipulated already. X is at the bottom of the fraction, so I'm going to read it upside down. Obviously this fraction says 4 divided by x squared, but I'm going to read it as x squared divided by 4, which is upside down. So now I'm going to say recip. Recip will flip it the right way up now. And then minus 3 is equal to 13. So I'm going to add 3 to both sides, add 3, and so that's going to give me 4 over x squared equals 16. And now I'm going to recip both sides, so opposite of recip is recip. I'm going to recip this one and recip this one. So on this side I've got to flip the fraction, so it's going to be x squared over 4, and on this side I'm going to write it as 16 over 1 and then flip it, so equals 1 over 16. Now I'm going to times by 4 times 4 times 4 times 4, and so that's going to give me x squared equals 4 over 16, which is a quarter. And then the last thing, opposite of square, is plus or minus square root, plus or minus square root, and then plus or minus square root, plus or minus square root. That cancels out with a squared, and it gives me x equals plus or minus a half. This time I think I'll check the positive a half rather than negative one. So 1 over 2 store as x, and then I'm just going to type this in, so 4 over x squared minus 3, it should be 13, it is 13, so I can write tick and checked. Tick and checked. Same thing again, we've got the x is at the bottom of the fraction, so we're going to read the fraction upside down, but it's also the term containing x has got a negative at the start of it. So I'm also going to swap those terms around. So I'm just going to pull this one over here and pull that one over there. Okay. So now my flow diagram is going to look like this. X, whoops, too thick, minus 4, divide by 8. I could say divide by minus 8, because that minus could just go on the top there, couldn't it? Instead of being there. Divide by minus 8. Divide by minus 8. I've read the fraction the wrong way around, so I need to recip to get it the right way around again. And then plus 4 equals 8. So we're going to minus 4 from both sides. Minus 4, minus 4. So it's going to give us minus 8 over x minus 4 equals 4. Now we're going to recip both sides. Recip. It's going to cancel that out. And we're going to write recip and recip. And so that's going to give us x minus 4 over minus 8 equals 1 over 4. And then opposite of divide by minus 8 is times by minus 8. So we're going to times by minus 8. Times by minus 8, that's going to cancel that out. Times by minus 8. And so that's going to give us x minus 4 equals, we're going to times by minus 8, so minus 8 is going to go on the top, minus 8 over 4. Well, that would just be minus 2 then. So let's just tidy that up to minus 2. Minus 2, and then the last thing is to add 4. And the last thing is to add 4. So x equals 2. Now you must lay out your workings like this. You must show what you did at each stage. You just reverse one operation at a time, showing what you're doing and then showing the result of it. So nice. Later on I'll relax this a bit, but for now I need you to get into the habit of doing this because it's getting your mind thinking in the right way. Okay, let's check our answer. We got x was 2, so 2 store as x. And then let's go back to the original question. So the original question wasn't this. The original question was, they had these terms the other way around, didn't they? So that was there, and that was there. Okay, so I'm just going to type in the left-hand side, 4 minus fraction 8 over x minus 4, 8 over x minus 4, and it should give me 8. It does, so I've checked that. Okay, a little bit more messy still again, but same rule as before. The x, this term here, which contains the x, is a negative term. So we should look at swapping them around. So we should bring that to the front and push this one to the end. And then it's easy for us to write our flow diagram. So our flow diagram now would be x square root minus 4 squared, divide by minus 2, divide by minus 2, recip. Remember, I read this fraction upside down. I started from the bottom and read it upwards, x square root of minus 4 squared, and then divide by minus. I put the minus on the top there instead as well. So, white will look better. So, I need to recip it, which I've done, and then plus 10. So my first step is to minus 10, that will cancel with that. And so that's going to cancel with that. And it's going to give me minus 2 over root x minus 4 squared equals 8 minus 10 is minus 2. Now I'm going to recip both sides. So I'm going to recip. In this case, that just means turning the fraction upside down. So root x minus 4 squared divided by minus 2 equals, in this you can think of it as minus 2 over 1. And so it's going to be 1 over minus 2. Doesn't matter where you put the minus. Okay, now I am going to, opposite of divide by minus 2 is times by minus 2. I'm going to times by minus 2. I'm going to times by minus 2. That's going to cancel. And so it's going to leave me with root of x minus 4 squared equals, well, a half times 2 is 1, and minus times minus is plus, so the answer is just plus 1. Now I'm going to square root both sides. Opposite of square is actually plus or minus square root, plus or minus square root. So plus or minus square root, plus or minus square root. And so that's going to give me root x minus 4 equals plus or minus root of 1. Root of 1 is 1, so 1 or minus 1. Still need to carry on. Still going to have to add 4. So I'm going to add 4 to this and add 4 to this. So that's going to give me root x. They're going to cancel out. Equals 1 plus 4 is 5 and minus 1 plus 4 is 3. And then the last step is to square. Square. That'll get me back to the x. Last step is to square, 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 square. I'm not squaring term by term because really that's one equation there and this is a separate equation. So really if you want to write that formally, you'd write that as root x equals 5 or root x equals 3, and there'd be two separate equations and each equation only has one term on the left and one term on the right, so you can square it quite happily. And so that's going to leave me with x equals 25 or x equals 9. Let's check the x equals 9. We'll check it in the original equation. So let's put it back. Okay, so we're checking x is 9 in here, so 9 store as x. And then we're typing in 10 minus fraction 2 over brackets root x minus, minus 4 close brackets and then squared. It does equal 8, so that's been checked. Okay, so this is your question 2. So you've got two questions as part of it. You've got part A and part B, and you need to solve them both. And you need to do a flow diagram, and you need to show how you used your flow diagram, and then you need to show that you checked your answer using the calculator. Okay, screen grab that. And okay, forming and solving equations. So here we're given a wordy problem and we need to convert the English into maths. So I think of a number. Well, if we don't know what that number is, why don't we call that number x? So we're going to call that number x. So this number is x. So we start off with the number x. What do you want to do next? You want to square it. Okay, you want to square it. So square it. And then halve the result. Okay, so now you're going to half the result. Okay, so you're going to half that. So you're going to half that. I subtract the answer from 27. So you've got to get this the right way around. Subtraction and division are always awkward. You've got to get them the right way around. Get it the wrong way around, it's going to ruin everything. I subtract the answer from 27. So I'm going to write that like this. You tell me if you agree with it. Minus 27. No, of course you didn't agree with it. Yeah, I didn't subtract 27 from it. I subtracted it from 27. So yeah, well spotted. So that's 27 minus. This is the answer from what we've done before. Then I square root it. Then I square root it. So then you square root it. And I get my favourite answer, 3. And so now it's equal to 3. But what was the original number? Well, we formed the equation, so now we can just solve it. Our flow diagram is going to be x squared times negative a half plus 27. I swapped them around in my head. I swapped these two terms around in my head. I put that one at the back and this one at the front. So it was minus a half x squared plus 27. Let's carry on with our flow diagram. Square root is equal to 3. Opposite of square root is square. So we're going to square both sides. So square, square. On this side, the square is going to cancel out the whole of the square root sign. So it's going to leave you with 27 minus a half x squared equals 3 squared is 9. And now it says we've got to reverse the plus 27, so we're going to minus 27 from both sides. So minus 27 minus 27. That's going to cross that one out. And so it's going to leave me with minus a half x squared equals 9 minus 27 is minus 18. Now my next step is going to be opposite of divide by minus a half. You can say that, of times minus half. You can say it's divide by minus half, or you can say it's times minus 2. I'm going to say it's times minus 2 because that just sounds nicer. So I'm going to times by minus 2, times by minus 2. That's going to give me x squared equals, the minus times the minus is going to be plus, and that's going to be 36. And then my last step, opposite of square, is plus or minus square root, plus or minus square root, and that will take me back to the x. So plus or minus square root, plus or minus square root. And so that's going to give me my answer, x equals 6 or minus 6. So the answer is 6. And we can just check this ourselves. We don't need to use the calculator to check it. I think of a number, 6. We said the answer is 6. I square it. So 36. Then halve it, 18. Subtract the answer from 27. 27 minus 18 will be 9. And then square root it and get my favourite answer, 3. 9 square rooted would be 3. Works fine. So this is your last question. This is your question 3. Think of a number. Subtract 1 from it. Not subtract it from 1. Subtract 1 from it. Reciprocal it. Square it. And then add 4. Lastly, I square root it to get 2.5. What was the original number? Okay, so form your equation, solve it, and then just check to see if it works. Okay, so these are the type of questions we're going to do in the classroom practice. A couple of them are yellow. What do you notice is different about those? And which are the questions where we're going to need to reorder the terms in order to write the flow diagram properly? Okay, So that's it. Don't forget to do your homework corrections and your test corrections. I will see you in the next lesson primer. Mena will see you at the weekend. Bye.